All right, we have now reached section 3, the open-ended section. So let's start. The first question is about a rational function. So let me get a pen right here. Okay, got it. All right, so you know what I'm going to do before I answer any question right here. I'm going to try to factor that. So let's see. How does that factor? F of x equals... Okay, so what do we have? We have 3x squared plus 3x minus 6. So I'll take a 3 out. And it's x squared plus x minus 2. And okay, I'm gonna try to factor that. 2x x. All right. Okay, so the product is 10 right here, right? The product is 10, and the sum has to be 9, but I'm gonna multiply one of them by 2. So let me see. Yeah, how about this? You get a 2 here and a 5 here, right? Because you get your 4 right there, 4 and 5. You can make a 9, and the signs are the same. So yeah, that's gonna work. Plus and plus. Okay. So let's finish the top. So what do we have at the top? We have. So let me rewrite 2x plus 5. Times x plus 2. The top, so that's x, oh, it's x plus 2x minus 1. Okay, this is... Okay, alright. Here, let's do one more thing. Let's simplify it. We're gonna have to be careful not to lose track of what we simplified, okay? But let's simplify it. So it's 3 times x minus 1 over 2x plus 5. Okay? Alright, so domain. Now for the domain, be careful, you have to read this one, okay? Don't read the simplified version. So we get x equals negative 2 out of that, and we get x equals negative 5. Okay, this is really getting to be by the sum. Negative 5 half. So it's negative infinity negative 5 half union negative 5 half negative 2 union negative 2 infinity. Okay? Vertical asymptotes. X equals negative 2 is not 1 because it's a 0 of both the denominator and the numerator. The only one is the one left at the end. X equals negative 5 half. Here we go. Whole. Yes, I do have a whole, and it's at negative 2. So, negative 2. How do we find the y-coordinate of the whole? So I'm going to plug negative 2 into that expression right here, right? You plug x equals negative 2 into it, and you're going to find the y-coordinate of the whole. So we have 3 times negative 2 minus 1 is negative 3, over 2 times negative 2 is negative 4, negative 4 plus 5 is 1, so it is negative 9. Negative 9 is negative 9 is the y-coordinate of the whole. X-intercept, well, that's easy. It's just this one right here, right? So it's 1, 0. Y-intercept, for the y-intercept, I'm reading this, and because x is 0, I'm just basically you just don't look at that, right? Because x equals 0, so that's going to be 0 plus 0, and so you're only left with this. Negative 6 over 10, so negative 3/5. negative 3/5. Oh, sorry. Did you see my mistake? Negative 3/5. Okay, maybe I can undo this. Okay, here we go. So the work will still be a little bit clean. Okay, all right. And behavior. Okay, so let's look at it. So same coefficient, right? Same. So it's not called the coefficient; it's called the degree. Same degree. So you do the ratio of the leading coefficient. So it's y equals 3/2. Okay, let's graph everything. Here I'll start with my 3/2, 1.5. All right. Vertical asymptotes. X equals negative 5/2. I wish I had some lines on the line here. Negative 5/2. There we go. Okay, negative 5/2. All right. Whole, -2, -9. It's -9, right? Yeah. -2, -9. Whole, -2, -9. So -2, -9. Here's a whole right here. X-intercept. X-intercept. Where is it? Right here. 1, 0. Y-intercept 0, -3/2. So x-intercept 1, 0. Y-intercept 0, -3/2, -3/5. So it's going to be slightly above. It's 0.6, right? We are done with the thing we can plug in. So I wouldn't mind a few extra points here. Look at the nice symmetry right here. So let me see. Let me count. I'm going. That's half, and then 1, 2, 3, and then 1.5. So half, 1, 2, 3, and then 1.5. I'm pretty sure this point is on it, right? It should be symmetrical, actually. And actually, let's do also this one. This is -9, -10. That's 10.5 below. So I'm pretty sure if I go to 10.5 above, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm pretty sure this point should be on it. What makes me say that? Symmetry with respect to the center right here. I believe this graph should be symmetrical with respect to the center. Let me take my calculator. And what I'm going to do, I guess I could have plugged the calculator right here, right? I'm going to put this function into y1 right here. I'm going to put this function into y1. So this function right here. I'm going to put it into y1. So it is 3x squared plus 3x minus 6, 3x squared plus 3x minus 6 divided by 2, don't forget the parentheses, right? 2x squared plus 9x plus 10. Okay, here we go. Okay, and then I'm going to check table of values. Okay, I'm just going to check the table of values. So table set, maybe start at 0, move by 1. Yeah, that's what I want. So tables of values. So that will allow me to get some extra points, right? Let me check my 2 points to see yeah, -6,3 is one of them. That's right. And I'm saying -312. Yep, absolutely. So these 2 points do check out. Okay, -4 it's -5. It's 5. Sorry, -4, 5 right here. I'm just gonna copy some point. That's all. -1 is -2. So right here, -2. And that should be, I think, enough. right? Yeah, the other ones are not as clean. 8 is 1. Oh, 8 is 1. So if 8 is, oh, it's out of right here. Okay, all right, it's time to graph it. Okay, so here, let me start with this branch. Okay, I'm turning to, I don't like that. You have to be a little bit meticulous, right? Okay, let's take care of that turn right here. Oh, shoot, it was really good except towards the end. Okay, that will do. That will do. And then turn smoothly. You remember smoothly? Smooth, it's a word I've used to describe this. Smooth actually has a very precise, measurable meaning in math. You may see that one day if you study math a little bit more. I think, no, it's not in calculus. I think maybe the next course. I don't know. Okay, here we go. Like that. Oh, look at that. This is not pretty. There's something like a corner there. Okay, let's just try to get this, the turn right here. All right, well, okay, still a little bit too edgy here, but that's fine. Okay, good. Okay, let's move on. Let me clean up all my yeah, you see, they're all here. Oh, look, an email from Natalie Perry. Hi, Natalie. Okay. More? No. Okay. Yeah, this one right here. This one right here. This one right there. This is such a pain. Such a pain. Yeah, I'm talking about you, computer. Okay, alright. Second question. Oh, what happened there? Why did you do that? Okay, I'll deal with that. Let me see. Okay, I don't know. I'll deal with that later. Second question. So this is the input of f. So I'm gonna get this on the x-axis, right? Oh, right. As I went over in class, because this is a function that has an inverse, then you know it has to be the graph that will have an inverse. So there's only one of the two graphs that has an inverse, and that's the blue one, right? The line, because it's 1-to-1, it passes the vertical line, the horizontal line test. While this graph doesn't pass the horizontal line test, therefore it doesn't have an inverse. Okay, all right. So this is the input of f. So I'm going to -6, and I'm trying to find the output of f. So the output is -3. So this is g of -3, and here again, this is on the x-axis. It's an input, right? X-axis. So, but now it's a function g. So I'm going to -3, and well, look, the output is right there, right? So it is 0. Okay, all right. So next question. What is g inverse of 0? Well, I mean, there's two ways to do that. First, you forgot what you just said, right? You forgot this right here. And this is the output. This is on the y-axis that you got to go fetch it, okay? So you go on the y-axis at 0, and you figure out where the input is. And the input happens to be at -3. yeah, f of negative 3. But actually, this is what I said right here. Look, I mean, if g of negative 3 is equal to 0, it's the same thing as saying g carries negative 3 to 0 if g inverse carries 0 to negative 3, right? So, and then negative 3, this one is on the x-axis, right? So negative 3 on the x-axis, and I want f. So negative 3 on the x-axis, and I want f. So it's going to be 6. Okay. This is on the y-axis, and I want the x coordinate of this. So 2 on the y-axis, right here. Where's the point on the graph of g that has a 2 for the y coordinate? This point right here, right? The y coordinate of this point is 2. Where's the point? Also, what's the x coordinate? The x coordinate is negative 1. So it is f of negative 1. Now, this is on the x-axis, right? So you read negative 1 on the x-axis. It's the input of f, and you want the output. Well, look, you go negative 1, and the output is 2 right here, because actually this point is shared by both f and g. So you're going back to where you started, because it happens to be a common point, okay? Okay, negative 15, that would be on the y-axis, right? Uh-oh. No, sorry, at the bottom. Uh-oh. Did I make a mistake here? So, what do we do? Do we do this? No, of course not. I don't need any graph to answer this question. The answer is negative 15, okay? You remember the property g of g inverse of x is always x. Likewise, g inverse of g of x is always x, okay? Okay, equations. All right, equations. So let's solve this equation. We've done plenty equations like that when we did the log and exponential. So the first thing you do is subtract 5, divide by negative 2. These are all if and only if, actually. Here you can look at it in two ways. You can apply ln on both sides. That's one way. Here, where can I'll do it right here. It's the same in both cases, right? Here, let me do it here. You can apply ln on both sides. Oh, that person me an email. Okay. Why do we do that? Because the left side simplifies to x squared plus 1 equals ln 4. Or other possibilities, and I'm going to make this longer. This is called the log form, and you can use the I'm sorry, it's not the log form. This is called the exponential form, and the base of the exponent is e. So you can rewrite in log form, so the base of the log will be e, therefore it's ln, right? And so you have x squared plus 1 equals ln 4. So of course you get back to the same place, okay? It's two ways of looking at it. Subtract 1. I'll continue here. Subtract 1. And, okay, here, I'll go a little bit further here. You don't have to do that. But if you want to show that you know how to deal with log, 1 is the same as ln e, right? And so ln 4 minus 1 is the same as ln of 4 over e, okay? And then, don't forget, plus or minus. Or plus or minus square root of ln of 4 over e. Now please be careful. Here, do I have enough room? Warning sign right here. You see a square root right here, and you may want to bring it inside, right? Be careful, be careful, be careful. Square root of ln x is ln x to the 1/2, and this has nothing to do with ln of x to the 1/2, which would be ln of square root of x. Okay, this, the 1/2 right here, is the output. Okay, for the output, what you have though, what you have is, when you have a 1/2 in front of ln, okay, then you can bring it inside for the input, x to the 1/2, which is, this is what, so I should say this right here, sorry. This is what square root of ln x, this is for the input right here, right? This 1/2 right here is for the input. Okay? Alright, I sometimes see students who bring the square root outside because they think they can apply this rule right here. Gotta be careful. Alright, let's do this one. I didn't have right here, if you look at the original equation, my variable is at the exponent and the domain of an exponential function. Okay, it doesn't matter what the base is. If you got y equals a of x, the domain is all real number. That's, as I've said a million times in class, that is the novelty. That's why we have an entire chapter dedicated to exponential and log, because now the exponent is real. As I've said in class, I don't know if you remember, you cannot, in Algebra 2 or in pre-calculus or even actually in calculus, you cannot rigorously approach the definition of a real power. It cannot be done, okay? So it's somewhat faked in high school, the study of exponential and log, but still you can use them a lot, but the rigorous approach of it, you cannot do it. So it's all real number, therefore you don't have any extraneous solution. It's all well defined no matter what. This equation, on the other hand, we're going to have to be careful. I'm taking the log of something, so at the end I got to make sure that whatever I found for x doesn't turn 2x plus 1 or 3x plus 4 into a negative quantity, or my log won't be defined. Okay, let's go. First step right here, I guess and here I cannot do that actually right here. What I'm about to write, this is a bit technical. It's not an if and only if, okay? And I'll tell you why. Give me 1 second right here. The solution of this equation right here may not be the same as the solution of this equation. Basically, when you apply the property of logarithm, this is when you can introduce extraneous roots. So actually it should be this right here normally, but forget about the technicality here, okay? Just know that you're going to have to check the solution here, and the steps at which you may be adding more solution to the original equation right here, okay, that's the original equation, is this one, okay, applying the properties of log. Okay, let's move on. So what do you do right here? Well, here I go. I'll go in both directions here, but here it's going to be a little bit more, not difficult, but, sorry, you're going to have to do something else here if you want to, well, we'll see. Sorry. If you want to, like the equivalence of taking ln on both sides right here and then getting rid of it, right here, you would have to rewrite the right side. And if you rewrite the right side, 3x plus 4 over 2x plus 1, that would be ln of 5. Okay, right? ln of 5. And then you can just drop ln on both sides, because ln is a one-to-one function, so if you have an equality of output, the inputs have to be equal, okay? So you just drop ln on both sides. Or else, you do exactly what we did right here, which is what I kind of recommend. You have to be able to move from an exponential form to a log form and vice versa. Here you have a log form, you would write the exponential form. So the exponential form is the input of the log becomes the output of the exponential. The base of the exponential is the same as the base of the log, and the output of the log is the input of the exponential. Here we go. Yeah, you've spotted the mistake right here. Sorry. Of course, 5 is not ln of 5. It's not the same. 5 is the same as ln of E5. So here we go. and here you drop the exponent. Sorry, see, it didn't work. So it's safer to do it like that, I guess, in the end. All right, let me pick it up from here. Oops, it's squeezed. So I got to solve for x. This is exactly the same procedure as in on the multiple choice answer when you had to find the inverse of the function. Okay, you had a y right here. It's exactly the same procedure. So let's do it. So 3x plus 3x plus 4 is equal to e5 times 2x plus 1. So actually, honestly, here it's non-leaf and non-leaf because I multiply by a variable expression. Don't worry about all of this technical stuff. I'm exposing you to it, but maybe one day it will make sense if you continue studying math. But right now it's really not important. Plus e5, I'm distributing. I want to put all my x's on the same side. So we have 3x minus 2e5. Hey, don't worry about the e5 right here. This is just a number, right? I don't know, it's like pi, it's just a number. It's like 5, negative 2, whatever. Equals e5 minus 4, right? I'm moving the 4 here and this term here. I'm factoring x. Okay, I need more room, so it's not going to work for me. So let's see. Tack. Here we go. That's going to work better. All right. Factoring x times 3 minus 2 e5 equals e5 minus 4, and so we have x equals e5 minus 4 over 3 minus 2e5. Oh, only one answer. Okay, why not? We got to figure out what it is about, right? We got to make sure it works. So let me see. I've taken my calculator now, and I'm entering this quantity right here. So e5 minus 4, don't forget the parentheses everywhere, divided by parentheses 3 minus 2 e5, here we go, and this is about negative it's about negative 0.5, okay? So what do I need to do? I need to make sure it's gonna work in here. So if I multiply this by 2 and then I add 1 plus 1, I will find, okay, so it works for that. It's gonna come out to be 0.01, oh sorry, 0.0170, blah blah blah. Okay, so it's fine, it's positive. Now if I take this, the x, I multiply by 3 and I add 4, I find, and this is about 2.5. So it works for both of them are positive, so I'm gonna keep this x, and that's my answer. Okay, this is the answer right here. Of course I want the exact answer. Okay, so don't circle the approximative value. Okay, here I guess I can circle stuff, maybe. Okay. Okay, it's 11:10 and I'm getting hungry. So I don't want to circle everything here. So I hope I'm going to be done quickly because I normally eat at 11 at school and my stomach is grumbling. Can you hear it? No? Oh, okay. Isa is calling her grandmother right now. Okay, how many students were originally sick? Oh well, I'll let you read the problem. how many students were originally sick? So originally in math means when the time is 0, and the time, or actually when the time or the input actually, okay, time or input is 0. And the time here is right there, so f of 0. So what do you have at the top? 850. At the bottom, 1 plus 84 times. Well, this is 0, so what is e to the 0? It's just 1, right? So it's 850 over 1 plus 84. Look how nice it is. 850 over 85. So it's 10. 10 students were originally sick. How many days will it take for 500 students to be sick? Okay, so what's going on here? F of t indicates the number of students, so what you want to do is solve the equation. 500 equals 850 divided by 1 plus 84 times e to what power? Negative 0.9. Negative 0.9 t, and you want to solve this for the time. So you remember what I'm going to do, right? I'm just going to flip-flop these two things. Again, this is not a magic trick. This is what happened. Oh, actually, let me stop using that. So it's not a magic trick, you know, it's a rule of equality. 84 properties of equality times e to the negative 0.9 t equals 850 over 500. Okay, divide by 10. Let's divide by 5, right? So it's 17 over 10. Oh, look at that. This is 1.7. Yeah, why not write 1. Well, I don't know. Let me leave it at 17 over 10. 17 times 5. Yeah. Okay. All right. So next, I'll subtract 1. So 84 times e to the negative 0.9 t equals 17 over 10 minus 1. So 17 minus 10 is 7. 7 over 10, right? So you divide by 84. I need more room. Make some room here. Okay. You divide by, where was I? I divide by 84. So e to the negative 0.9 t equals 7 over 10 times 84. Oh, look, this is 7e plus 14, right? So when you divide by 7, you get a 10 out of that, and you get a 2 out of that. Sorry, I don't know my multiplication of 12. So it is 12. So you divide by 7, you get a 1, and you divide by 7, you get a 12. Okay. So it is 1 over 120. Okay, all right, let's continue. Oh gosh, I'm gonna erase this, okay? So let's take the log form of it. Let's take the log form of it. So 0.09 t equals 0.09 t equals ln of 1 over 120, and so you divide by 0.09, right? So t equals negative 1 over 0.09 times ln of 1 over 120. Now, the negative sign, you know, negative can go at the exponent right here, and a fraction to an exponent, you flip the fraction, right? I told you I do that all the time, just to make my expression easier to understand. So it's ln of 120 divided by 0.9. Okay, 0.9. So what is that? What is this? Ln of 120 divided by 0.9. and this is about 5.32. So I need to read the problem to see what it's all about. 5.32. Describe the number of students at school after a student came to school. T days. 5.32 days. Round your answer to an entire number. So this is about. So this is the way I'm gonna say it. Okay. So it's about 5.32. So I'm gonna say it will take about, to an entire number, so not 5, because at 5 you don't have 500 students sick. Okay, not 5, it has to be 6. 6 days for 500 students to fall ill. Okay, all right. What is the limit? Okay, here's the limit question. Okay, so to answer this question, you have to look at the. Okay. If you look at the graph y equals e to the t, I'm going to put t right here, why not? It doesn't matter, right? And x and y right there. E to the t, it goes up, right? So actually e to the t, or if you put 0.9t, it still go up. You remember what that does? I think it's a dilation because it's smaller than 1, so it's gonna dilate on the x-axis, but it still goes up, right? So now what happened if you put a minus sign in front of the input? You turn x into negative x, so the graph is gonna go like this, right? If you turn x into negative x, the graph is gonna go like this. So this is like y equals e to the negative 0.09t, okay? And the limit as t approaches infinity, how do you read the question? You read it by looking at this part of the graph. So limit of e to the negative 0.09t as t approaches infinity. Oh, what's going on here? Okay, got it. Is 0. Okay, I can see it right here, it's 0. What is the limit of f of t? So let's write f of t. So limit as t approaches infinity of 850 over 1 plus 84 times e to the negative 0.09t as t approaches infinity. So what, of course you're going to use the previous question, this piece right here, this piece is approaching 0. And you multiply this by 84. Therefore, you multiply 0 by a number, you're still gonna find 0. Okay, right? And what happens when you add 1 to 0? 0 plus 1 is not 0, it's 1. And so what happens now when you divide 850 by 1? You find 850. Interpret the meaning of this problem. So as t approaches infinity, you know, this function measures the number of students who get sick. So this is the maximum number of students who can get sick, right? The maximum number of students who can get sick on a given day, not the total population at the school, on a given day is 850. Now, what does it mean? It may represent the students, the total number of students in the school, but it may also represent like a balance, you know. Students are going to get sick, they're going to be sick, but other students at the same time will get better. And when the ravages are maximum, when the maximum number of students will get sick, you know, it's going to be the number of maximum students we'll see will be 850, meaning like there would be a balance between the students getting sick and the students healing at the same time, and that's going to be 850, okay? All right, whatever, it's just a maximum number of students who will get sick on a given day. Okay, let's stop the video right here.